Okay, this video is what causes insulin resistance, what causes diabetes. It's going to take 3 parts. It's coming from this book right here, Prevent and Reverse Parkinson's Disease and Chronic Fatigue Syndrome, written by me, Pete Rogers. I'm going to start out giving you the background of diabetes, and then I'm going to go through not just the most common cause. I'm going to go through uncommon, minor causes of insulin resistance. This is for the idea that if a person has diabetes, they want to optimize everything so they can, if they're lucky, stay off drugs and cure themselves, possibly. Okay, this is just an educational video, not your doctor, but I'm teaching you how diabetes work. And I can tell you, all medical schools, their lectures on diabetes stink. All conventional medical textbooks on diabetes, they stink. They're embarrassment, they're a joke, they're a disgrace. Okay? So this is information at a higher level than is possible to obtain in the conventional medical world. Okay, we'll start out talking about diabetes. Diabetes, people say, oh, it's a disease of sugar and carbohydrates. No, it's not. That's a symptom. It's a disease of fat metabolism, okay? All right, it starts out with accumulation of fat in the skeletal muscle, and that causes, after eating, high blood glucose, postprandial hyperglycemia. Then the fat accumulates in the liver, so that's called fatty liver. And then you get fasting hypoglycemia, so when you're not eating, you're hyperglycemic, high blood glucose around the clock. Later on, the fat accumulates in the pancreas, and you get fatty atrophy of the pancreas with destruction of the beta cells of the pancreas, and you lose the ability to make insulin. Then the person becomes an insulin-dependent diabetic. We're talking about type 2 diabetes, which is the vast majority of diabetes, okay? And it is primarily caused by eating a diet excessively high in fat, but there's other things that contribute to it. And then this illustration is of the secondary complications of diabetes. Okay, and part of this goes back to the idea by Gerald Shulman. Gerald Shulman is an MD, PhD, genius researcher out at Yale. He is, graduate like a Harvard, MGH, endocrine fellowship. And he was using nuclear magnetic resonance spectroscopy looking at the skeletal muscle, and the earliest detectable finding of insulin resistance was the accumulation of fat in the skeletal muscle. Okay, and then I sort of made up this fat staging system, which is really just based on his idea of ectopic fat theory, of that, the fat goes from the muscle to the liver to the pancreas, okay, and progressively destroys the patient's ability to handle their blood glucose, okay. There's always more to it than that, but that's the general idea. So how do you avoid it? You minimize dietary fat, okay? You optimize your body weight, okay? And then I'm going to go through how all these common side effects occur. Okay, so normally after you eat a meal, about 80% of your glucose should be going to your skeletal muscle. Most of it's stored as glycogen, and it's just stored for the individual muscle. The liver's different. The liver glycogen is stored for the entire body to maintain blood glucose. The main job of the liver is to maintain blood glucose during fasting for the brain, because if your brain is without glucose, your brain cells will die. Okay, that's the main thing the liver does. Okay, so after you eat a meal, you store the glucose, you make a bunch of glycogen, then during fasting, you break down that glycogen to provide glucose for the blood, for the brain. And if you don't have enough glycogen, then you start running a pathway called gluconeogenesis, which is very much like glycolysis backwards, synthesizing glucose that can be released into the blood and go up to the brain, okay? And you can use amino acids to do that. You can also use fat. You take a triglyceride, you can take the glycerol backbone, that's a 3-carbon backbone, and you stick 2 of them together, you can make a glucose. And you can just burn the extra fat in your brown fat, so to speak, for heat. Okay, that's what gluconeogenesis is. Okay, so eating is prandial, so postprandial means right after eating. What happens when you eat a large amount of fat is it creates something called overnutrition. Overnutrition means that it sends too many electron carriers up to the inner mitochondrial membrane electron transport chain. Okay, the mitochondria has 2 membranes. The outer membrane is OMM, outer mitochondrial membrane. The inner mitochondrial membrane is IMM, inner mitochondrial membrane. And these are protein complexes that pass electrons like a fireman bucket brigade passing the bucket down to the next person in line. They pass them down a gradient of electron grabbers. Electron grabbing ability is based on what's called electronegativity. And the highest electronegativity is coming from oxygen. It really wants those electrons, and it grabs them very forcefully. Okay, and that's why oxygen is the ultimate electron grabber in electron transport, and it's the last step in intermitochondrial membrane electron transport. Simultaneously, these proton complexes are pumping protons, this is the hydrogen nucleus, into the intramembranous space. Intramembranous meaning between the inner and the outer membranes. And then you're building up a gradient, kind of like pressurized air, a pressurized gradient of protons, okay? And that's potential energy, okay? And then it's harvested, becoming kinetic energy when the proton is brought back in through complex number 5, which is called ATP synthase. And the energy derived from letting that like pressurized air push through the ATP synthase rotates it. And when it spins, what is linked to that is a adenosine diphosphate with 2 phosphates, gets a 3rd phosphate added, becomes adenosine triphosphate, as in having 3 phosphates. And ATP is the energy currency of the cell. It's like a $20 bill on a cell for getting work done. So that's how energy is made. Over 90% of ATP energy is made through this process there. And with the use of oxygen and the addition of a phosphate, it's called oxidative phosphorylation. Okay, and that is the best, most efficient way to make energy. When you make energy in this way, you make about 18 times as much energy from a molecule of glucose than you would if you just ran it through anaerobic metabolism. So this is aerobic metabolism. Okay. Now, excessive dietary fat messes things up because the fat gets into the mitochondria too rapidly. And the worst one is saturated fat. Because saturated fat doesn't have any double bonds, it generates more electron carriers than a PUFA does, a polyunsaturated fatty acid, and thus it's more predisposed to causing insulin resistance, okay? And this causing of insulin resistance is also sometimes called overnutrition. Too much nutrition getting into the mitochondria too fast. So it says, hey, we got too much nutrition in here, let us shut down our plasma membrane and do not allow any glucose to come into the cell. Okay, so first of all, we'll briefly talk about what insulin does under normal circumstances. Under normal circumstances, insulin binds to an insulin receptor. And once it's bound to the insulin receptor, it activates a cascade of reactions that signal to the glucose type 4 transporter vesicles. These are sitting in the cytoplasm. And these vesicles, membrane-bound vesicles, travel up to the plasma membrane, merge with it, and then they release these glucose type 4 transporters to sit inside of the membrane, okay? Once they're sitting inside the plasma membrane, they then form a channel that glucose can enter the cell. And as soon as glucose enters the cell, it gets phosphorylated to put a charge on it so it can't exit back out. And that's how you take glucose into the cell after a meal. If you exercise, you get the same effect. Glucose type 4 transporters go up to the plasma membrane. When you have overnutrition, though, insulin will stop working. I'll show you a picture of what that looks like. Okay, here's a picture of insulin resistance, the drawing of it. In this setting, you've got excessive fat accumulating in the mitochondria, causing the overnutrition problem, and that leading to a signal being sent out to the cytoplasm to not allow the glucose type 4 transporters to go up to the plasma membrane. So that shuts down glucose type 4 transporters getting into the plasma membrane, and therefore these glucose molecules in the blood, they can't get into the cell. And so blood glucose level starts going up. You get hyperglycemia. This occurs after eating a meal, so this is postprandial. So this is postprandial hyperglycemia, after eating high blood glucose. Okay, and there's something called carbohydrate intolerance. What that means is if you eat the fats first, you'll get the insulin resistance, and then if you follow that by eating your carbohydrates, then the glucose that comes, into your blood from those carbohydrates that you've eaten, they won't be able to get into the skeletal muscle. If you just ate the starch alone, it's normal to get a little bit of bump in your blood glucose curve. But if you eat the fats first, inducing insulin resistance, then you get a big increased amount of insulin resistance, and you get a much higher and a more prolonged blood glucose elevation, blood glucose spike from doing that, okay? So I'm going to call that the end of part 1. In parts 2 and part 3, I'm going to go into much more detail about all the nuance of insulin resistance with the idea that you'll have more ability to help someone minimize their insulin resistance and hopefully improve their health. So I hope you found that helpful.